We are going to pick up the tangent construction. Okay, one simple tangent construction we will do. Yeah. Suppose there is a radius given. Let's say radius is 3.5, and I have to draw a tangent from an external point. Tangent from an external point, which is going to be, and I need to make two tangents from an external point that is at a distance of let's say 7 centimeter from the center of the circle. So let us read it. I mean, this is a good question. Sometimes they can give you diameter. Not a big deal. Diameter is given. Still, you can do the construction. Just do the half of it. You can get the radius. Okay. Same question. I'm not going to repeat it for that. Diameter can also be given instead of radius. So in that case, just do half of that for the construction. So I'm just giving you the rough idea what we do, and then like with me, you will do those steps. So we need to have a circle drawn. This is going to be of 3.5 centimeters. Okay, and what did they say? There is a tangent to be drawn from an external point. There's an outside point which is at a distance of 7 centimeters from the center. This is your center. You will use your scale from that center 7 centimeters. So of course I get an idea that this is 3.5, so double of that will be this 7. Okay, but here you don't have to technically yeah, you can join it rather. Here you can join it this way, a straight line. Okay, and this is that example. Let me call that as P. If it is not given, you can give it a name from your end. And then, yes, so what you can do right now, you can do it with me then. Draw a circle of 3.5. Okay, mark all the things, like all the dimensions given, put that thing with pencil and little neatly and small. You don't have to make big writings for the measurements. Make it little small. All this marking is important. Later you can put up, after your construction is done, with a very small precision of pencil, you can put a line and then you can go to 7 centimeter. This you can do it later about the 7 centimeter. For now, you will draw up till this point. This is your point external point. Once done, then tell me. It has to be a straight line, okay? This is going to be a straight line connecting. Yes. So draw till that point. Now what you do? Yes. So this is your complete segment. Now we're going to do a perpendicular bisector. Now we're seeing how to do angle bisector. Perpendicular bisector is very simple. Now these 2 points you have joined, OP, that's a segment. And keep the compass, extend it, keep it at O, extend it such that it becomes more than half. That's your rough idea. Don't do it with a very particular precision. You have a knowledge that this is going to be half. Take a little bigger length of it, more than half. Make a cut on the top and bottom and don't move that compass. Place it at P, make a cut on the top and bottom, and you're going to join them. Okay. Now, technically, for this particular construction, this line is going to be exactly at this point because that's 7. So half of 7 will be 3.5, and 3.5 is this length, right? So if you do your construction, just make sure this is how your this is how your bisector will be. Okay, but that's not your tangent.
And where do we have to keep the needle of the compass?
To do the perpendicular bisector, OP, that's your length, right? We do a perpendicular bisector. So for perpendicular bisector, that's the idea. We take more than half. And it will be exactly coming at the center and it's going to be at 90 degrees. So if you want, you can take it like 3.5 more than that also. But 3.5 will give you a small little arc, which will be coming little close to the surface. So this is how segment bisectors are made, like perpendicular bisectors are made. Whatever is the segment, from our knowledge, take little or length bigger than half. That is not needed to be done with measurement. You get an idea that this is half, take little extended part of it. That's it. No particular measurement is required. So you're going to get this part. Once this is done, then tell me how far you're getting this construction. You can check that. Wherever that bisector is formed, let's say in this case it will be somewhere over here, right? Let that be given a name. I'm giving it a name as Q. Keep the compass needle at Q and extend the Q till O. You can take O or you can take P. That's up to you, because when we say perpendicular bisector, that point will be equidistant from one end as well as from the other end. So it's up to you. You want to take it to the left side or right side. Take any one point, and this is going to be radius, and you're going to be very precise about it. So Q is your needle point, and extend it till one end and draw a circle. And it would be good that you draw this circle with a dotted part, or if you completely draw it, just try to use eraser and make that marking. It's okay, like even if it is solid, that's still okay, but this is a good way to put up your paper into good presentation form. So this is a circle you will get. Once you get that circle, I mean, do that part, then I'll tell you the next step. Circle is completed. Now, this is that point, that external point from where you had to draw that two tangent. Now, this circle, the second circle you've drawn, it's cutting through the previous red circle. Let me call this as A and let me call this as B. Okay, these are the 2 points where this big circle is cutting the previous circle. These 2 points, you're just going to join it through P. So this, using a scale, you will join it. And that's your required tangent from that external point P. And you can always check if your construction is going right. Use the scale and check the length of PA. PA and PB will be equal, because that's the property of tangent. We know that whenever there are tangents drawn from an external point to a given circle, the tangent segments are always going to be equal. So we get to know from construction that these two will be same, and these two are the triangles written. Kind of tangent questions, and definitely asked with steps of construction. So steps of construction is every time you do a step, like you draw, like in the initial part you've said, draw a circle of radius 3.5, then take a point P, which is at and then you can name all this, centers O. Take a point P, which is at a distance of 7 cm. So OP is 7 centimeter. Then you can see, or do the perpendicular bisector of OP, which bisects the bisector is point O. And then you will write, taking OQ as the radius, draw the circle which intersects the previous circle at point A and B, and then join PB and PA. So this way, whatever step you're doing in the construction, at the same time you can keep writing it out if it is specified, and if it is for like 3 marks and plus, steps of construction will be required. Okay, now let us make a, now this kind of question was a tangent which is from an external point, it's outside the circle. Let us draw a tangent which is going to be exactly on that circle from that point. That is, like if you have a circle given, this is the center of it, and this is how the tangent has to be. So this tangent will be of this side, okay, or anywhere. It's not necessarily the right side. The previous case was from a point, two tangents you have drawn, and this is a straight tangent which is going to have 1 point. Of course, every tangent has 1 point of contact. That is from the external point, and this is exactly on the point. Okay, so here the first case is where we know the center. The center is known to us. Okay, so it's pretty thing that even in the second case we know the center, but this is the idea, like without taking the center point, we are going to be doing the construction. So the first case is you will draw a tangent to a circle that lies on it. Lies on it means on the boundary. And let us take the case of radius as 3 centimeter. Take anything, like I'm just giving 3 centimeter. Do the first step, draw a 3 centimeter circle. And you're going to take a point on it, right? So this is point O, and that point has to be a point on that circle. You can take anywhere. Conveniently, I'm taking it here, and let me call that as P. Method is saying that time the P was little far away with some measurement. This time P is exactly on the boundary. It is the same. I have a circle. So you don't have to do the bisector then. Taking this as a center and taking a random point P, obviously this will be common. You will be taking, joining OP. Then I told you how to do construction of 90 degree, correct? And here you will not be using the uh, protractor. That is not allowed. You cannot directly use protractor for the 90 degree, 120 degree. You will join it because they get to know. All the examiners, they know you have used the protractor directly. They expect that basic construction for all the base degree that we have covered. So you will extend this a little bit for that arc to be formed. This is your point from where you will be drawing the tangent. Keeping this as a step, now I told you how we will draw it. Keeping this as a point, make a semicircle. Okay, and now you can take it from this end or you can take it from that end, or the 90 degree will be exactly at the center, right? If it is convenient for you to take it from this end, you can do that. First cut is 60. You don't have to draw the 60 and 120. Just make cut so that we will take that as your base for 90 degree. First cut, just make arc, don't draw the line. And the second one, first cut is done, then the second cut is done. Only do the cuts, don't draw any line. And use the compass needle, place it at this arc, and you can, you have this idea, this is this big. So place it with a bisector way. So that is more than half idea. Make a cut here, place it here, make the second cut here. Okay, so technically when you do that in your book, it will be passing through this, and that is your 90 degree. And we have that property of tangent, that tangent brought to the circle is always going to meet at 90 degree if it is a line coming from the center of the circle. That is, this is your radius, right? Radius is always drawn from the center of the circle. And if it meets the tangent, it will be at 90 degrees. So we are using that property to implement our construction. And just try to extend this way, and this is your tangent. I mean, this would be much faster and easy way where the center is taken as your reference point. So from center, you will join that point. You can take it anywhere on the circle, but it is more easy for us to do a construction of this way. If you take it the point here, that is also fine. Then join OP and then extend this line. Then this is how, but then for that, the whole book and the page has to be turned around. This is going to be more convenient with the kind of orientation of your page. Okay, so join OP, make the semicircle. First cut is 60, second cut is 120, and between that the bisector is 90, and directly use a scale and connect them. And this is going to be a required tangent, and always give us top and bottom marking. Suppose I am writing T, you can write some other term like, or T dash also you can write, or you want you can write Q. So this T, P, Q, this is how you read it, considering that P is coming as the point of contact. So this line can be read as TP is the required tangent. Okay, so do the construction, see how much your case is same thing. You will draw a circle, let's say of 3 centimeter, 3.5, let's take 3.5. Okay, 3.5, and we need to draw a tangent. Okay, first of all, draw 3.5. We know there is a center, but don't use it. We're not going to use that. We're not going to join it to any of the points. Okay, and then once ready, then we can take a random point. The concept of the point taking will be same, because here also we're going to take it through one of the point. That is technically this case in the previous cases where the point of contact is taken and then we're drawing the tangent. The very first case was point from an external point, which is nowhere lying on the circumference of the circle. So we can take a random point. I'm taking the point here. Okay, and we are going to draw a chord. Now that chord can be this way. Let us draw a chord. So this is P, this is Q. Now this is the chord. So in the second case where we're not taking center as the reference, we will be taking chord as one of our reference. But we don't have to do any bisector here, but equal angle is what we will be doing. Before doing this construction, let me give you that how you form equal angle. Suppose an angle is given to you. It's a given angle. I want to make a similar angle, exact angle or congruent angle, or let's say equal angle. And I have the base with me, but I have to match it without using the protractor. This is the sample, and I want to make the same angle. How I do that? So suppose this is that angle, you will use a compass needle. Okay, let's say this is the base of it, the origin point of it, and that's the origin vertex of it. Keep the needle here, make the arc. You will get that arc. Don't move your compass. Keep the needle here, you will make that arc. Okay, then wherever the arcs are, connecting the two, points, these are your intersecting points. Keep the arc, I mean that needle over here at the arc, and reduce it exactly to the same measurement. This you have to do very precisely. Okay, I have to have a good focus. So this is going to be the length of it. Don't move it. Keep it here because that's one of the point of intersection that we got. Keep your needle here, and where it is going to cut that up, you will make a cut, and then you're going to, this is just like an idea, and then you're going to join it from the origin. So this way you make equal angles. Okay, so try this before you take this construction. I want you to try this point, and if you have protractor, then check. Like this is a certain degree, and that has to be same with the second one. Check that. Now so here we are not going to touch the center point. Okay, we're working with the chord. And the point of reference that we're taking is P. This is from the point from where I need to draw the tangent. So first I'll draw a chord. Chord is obviously not going to be going through the center. And this is going to have the major and minor arc part, right? So in the major arc, this is your major arc. Because of the chord, there are two arcs you get. This one is the minor arc, small arc, and the circle's major arc is on the top portion. You will pick up one random point on the major arc. That's up to you. It's not, it's not like you have to take it here or there. You randomly take it, and let me call that as R. Then what you need to do is join this PQ and this PR. Okay, so do that step. Take a random point on the top portion. Obviously, you get to know that. Don't take it at the bottom portion. It becomes very complex for us to do the construction. Take that point on the major arc and join PR and PR and RQ. Once you're done with that, then tell me. Anywhere, yes. You take any random point. You have taken this circle. You thought, okay, let me make the point of contact here or maybe here. Totally fine. This is your point of reference. And then you can draw a chord to this part, you can draw a chord to that part, or you can draw anywhere. But just make sure it's a chord. It's not going to the center. You can make it anywhere. I've taken point P here. That means my tangent will be in this way. Okay. If I would have taken P here, the tangent would have gone straight. It totally depends where you're taking your point of contact. All right. Yes, this is done. Now, again, the same thing I told you, we're going to use the angle concept. Now, there is this angle formed PRQ. This is that angle. All right. Now, what am I going to do? This is a different thing. That one I gave you was with a base segment, but from a point also we can do that. That we can implement here itself. So what you do, this is your point, and you're going to make an arc, which I've already drawn. Taking R as your base needle, make an arc. Okay, that means taking P, you're going to make an arc, and that arc will obviously try to cut the Q. You're going to take a bigger arc like this. Then, whatever arc you've drawn here, taking P, you are drawing arc, only simple arc. Then you're going to take the angle that I told you. How you're going to do that measurement? The two intersected points of that arc. You're going to adjust your pencil and the needle. Okay, and then if you're taking this this angle, this is your base. Okay, If you want it is difficult, you can move your page around for better convenient way to put up your construction. So this is going to be your base. Okay. And keeping this point, let me mark it here. If you're confused where you're going to keep the point, this point I'm going to call, let's say, PQRS. Okay. So this angle and this angle has been made. Of course, it will cut through that PQ, and keeping it here, you will make that cut. Whatever is the measurement on the top, make a similar cut. Okay. And then you're going to join this. This line, you're going to join it this way. You got this angle. Technically, what you're doing, let me call this as PQRST. This is the point through the P. Let me call this as T. What you're doing here is PRQ. You're making that equal to S, sorry, not S, Q, P, and T. This angle over here and this angle over here, they will be equal. But this doesn't look like a tangent. Then use your scale and simply extend it. Use your scale and extend it. Whenever you do extension, you can always put it in a dotted way. If it is T, you can write something else or put T dash. That's it. And this T dash P T. This is your required tangent. Okay. So P dash P T is the required tangent. So here we have not touched the center. We have not used the center at all. But we have made use of chord concept to do it. So I'll repeat this quickly with whatever we have done. The very first diagram was from an external point. Okay, if there is a length given to you, you will join it, make bisector. So that is keep more than half and do this cut on the top and bottom. You get a bisector. Now from that bisector, you can choose this point or that point. Let's say it's O and this is P. And make your circle. Now this circle is cutting the previous circle at 2 points and simply join the lines through P. That's your two tangents from the external point. Then we have done this one where we have taken, we are utilizing center as your reference for tangent. So this is O. Okay, we can take any random point. Let's say I want to take it here. Here we are going to use the center, so join it. Okay, and extend this a bit so that you're making that 90 degrees. So putting this point as your base point, origin point, you make an arc. First cut is 60, second cut is 120, and bisector of that will be 90, and join it through P and extend it. That's it. This is using center. And then comes this type where you are not referring your center, but you use chord. So you have a circle, then a point here, but don't use it. Take a random point anywhere. Let's say I've taken it here. Okay. Or let's say I've taken it here. And draw chord. Now, if you want, you can draw this way, that way, whichever way. So I'm drawing it this way. So let me call this as P and Q. And take this becomes the major arc. So I'm going to take a random point here, connect these two, and PQ will be your base. P is where you're going to do that whole similar angle. Keep your arc here, cut it. Don't move it. Place the same compass needle here. Cut it through such a way that it will be touching that Q. I mean, the Q segment, PQ segment is being cut through. Then use the compass adjustment is done here. And same thing, you're going to keep it at this point of intersection. That adjustment is cut through in the form of arc. And then you're going to join it like this. And just extend it with a scale. So your required tangent will be drawn this way.